going to present a formal theory of consciousness. It's precise, but it may be precisely wrong, and that's the point in science. We've already talked a lot about physicalist theory, so a lot of the hard work's been done. I would just say that what we want from a physicalist theory of consciousness is a theory that would explain with mathematical precision, for example, what precise brain activity causes my experience, say, of the taste of chocolate, and why that precise brain activity causes that taste of chocolate. What change in that precise activity would change the experience to the taste of garlic? And why would that change make that precise change? In other words, we want laws that take brain states, functionally described, biologically described, however, and give us precise laws that predict precisely the reports that our observers would give about the kinds of conscious experiences that they're having. Now, there are, as we've talked about today, a number of physicalist theories, integrated information, OR. No one's even trying to do this. This is something that we would definitely like in a consciousness theory. No one is even looking at this particular question. The issue, for example, I guess I should back off a little bit. There are attempts, but I would say that there are attempts that are not working very well. We'll go into it in a moment. So that's why this consciousness conference, I think, is properly called Towards the Science of Consciousness. We're not there yet. When we're in such a deep trouble in terms of getting a scientific theory, it's time to question assumptions. I'm going to question one deeply held assumption, that perception is normally veridical, and that physical objects have causal powers, and that brain activity causes consciousness. These are wild things. These are apple pie for most of us. I'm going to question them. And to start with, I'll just go back and talk just a little bit about what's standardly thought about visual perception. So roughly a third of the brain's cortex is engaged in vision. When you simply open your eyes and look around the room and see the objects and colors and so forth, billions of neurons and trillions of synapses are engaged in just opening your eyes and looking at the world. And this could be surprising for most of us if we think of perception, vision, as being like a camera, where there's an objective 3D world with objects and colors and shapes out there, and all vision does is take a snapshot of that pre-existing objective world. Clearly, you don't need billions of neurons, trillions of synapses to do that. So why do we have them? Well, the standard view in cognitive neuroscience right now, and also machine vision, is that perception is construction. You're not taking just a picture of the world. You are constructing in real time all the depths, colors, motions, shapes, textures, and objects that you see. So when you close your eyes and then you open your eyes, within, say, 100 milliseconds to 200 milliseconds, all these neurons, the story goes, are constructing all these properties so quickly that you have the illusion that you're seeing the world as it is, but you're in fact seeing the world that you construct in the moment. I'll just give you a couple examples that you may know of this that are quite popular. The top and the bottom may look different shades of gray, but in fact they're identical, and you can close one eye and put your finger over the line between them, and you'll see that they're in fact identical shades of gray. So your visual system is constructing all the shades of gray that you see. It's not just a raw camera picture. And in this display, you may see blue bands with clear edges going across the screen. There are no blue bands. You're constructing those. The edges are your construction, and the faint blue is your construction as well. All I've done, nothing's moving. All the dots are static. I'm just changing the colors of dots from black to blue and blue to black. But I'm doing it in a regular way so that your visual system then goes to work and constructs these bands. And there's many, many examples. It's a fun talk to talk for an hour, just showing you tons of examples like this. Great stuff. What I've said so far is standard in the field. Perception is construction. It's also standard to say that our constructions of depth, shapes, colors, and motions are in fact reconstructions of the true depth, shapes, colors, and motions that are out there in the world. So the idea is that, yeah, perception is construction, but those constructions are really estimates of the true properties of a pre-existing physical world. And the argument typically given for why our perceptions are good estimates is an evolutionary argument. The idea is simply those of our predecessors who didn't see as truly were at a competitive disadvantage vis-a-vis those who saw more truly. They were just a little bit less likely to have kids. And so over thousands of generations, we are the offspring of those who saw a little bit more truly, so we can, by and large, trust our perceptions, except when we're in psychology labs. So perception is generally vertical, and almost every vision scientist believes this. So just to give you a couple quotes, the standard textbook that's used in graduate studies in vision science by Steve Palmer says, evolutionarily speaking, visual perception is useful only if it's reasonably accurate. Indeed, vision is useful precisely because it's so accurate. By and large, what you see is what you get. When this is true, we have what's called veridical perception. This is almost always the case with vision. Geisler and Deal say, in general, perceptual estimates that are nearer the truth have greater utility, in an evolutionary sense, than those that are wide of the mark. And I have half a dozen other slides from other people all saying exactly the same thing. I think there's not a person in the field who's talked on this who hasn't said basically the same kind of thing. Evolution guarantees that our perceptions in the normal case, outside of psychology labs, are vertical to a good approximation. And I think that this misunderstands evolution completely. So here's a technical question. Does natural selection actually favor vertical perceptions? That's a technical question. We don't have to hand wave, we don't have to guess. Evolution is a mathematically precise theory. We have evolutionary game theory, genetic algorithms, and now the new science of evolutionary graph theory. We can create as many artificial worlds as we want. We can, with mathematical precision, create perceptual strategies that see all of the truth, part of the truth, whatever part of the truth we want, and some that see none of the truth, but are tuned to the fitness functions in our games. We can run millions of simulations and see who wins. So it's not a matter of intuition or guessing anymore. It's a matter of mathematical modeling. Before we get there, I'll just give you some intuitions, though, about why we might want to rethink about perception and true perceptions coming from evolution. This is the jewel beetle, Julodimorpha backwelli, that lives out in the Australian outback. As you can see, their wing casings are bumpy, glossy, and brown. The males fly, the females are flightless. The males fly around looking for females, and when they find an eligible female, they alight and mate. There's another species in the outback, Homo sapiens. The males of that species like full beer bottles. They don't like empties. They toss the empties out, and they call them stubbies, into the Australian outback. And those bottles, as you can see, are bumpy, glossy, and just the right shade of brown to cause this beetle to be quite excited. So what happened was the males swarmed the bottles, the females weren't getting any, and they had to pass laws. They had to pass laws or the species would have gone extinct very, very shortly. So here's a situation where the beetles had, the male beetles had been successfully finding females for hundreds of thousands, millions of years. It looked like their perceptual systems were really quite smart. In fact, they had a simple hack. Evolution had made their perceptual systems have this little trick. Look for something bumpy, glossy, and brown, the bigger the better. And that worked. In their niche, it worked. All you needed was a little disturbance to the niche, a few beer bottles, game over. They're gone without the laws being passed. And in fact, 99% of all species that have existed are gone. You might say, well, beetles, sure. Not mammals. And you know where this is going. I won't go on to this too much, but you get the idea. Okay. So there is reason to believe that maybe in some cases, not all of our perceptions are veridical insights into the nature of reality. I think Pinker has a good insight on this. Pinker, in his book, How the Mind Works, says, we're organisms, not angels. Our minds are organs, not pipelines to the truth. Our minds evolved by natural selection to solve problems that were life and death matters to our ancestors, not to commune with correctness. I think that's the right point of view on this. So now we can test this. We can use evolutionary game theory. So as I said, we can first define perceptual strategies. We can talk about truth strategies and various nuanced versions. So it's not just truth versus no truth. As many nuanced versions as you want. With mathematical precision, we can spell them out. So we say what the worlds are, what the precise mathematical maps are from those worlds to the perceptions of the artificial organisms. So for example, we have many versions of truth, and something that I'll tell you about later called the interface doesn't see the truth, but it's tuned just to the fitness functions in the game. We have them compete, and we can charge them for various costs in time, information, and computation. There are no free bits of information. There is no free computation in general. Every calorie that you use to do computations and perception, you have to go out there, kill something, and eat it to get those calories. No free calories. And what we find, and this was published in the Journal of Theoretical Biology just a couple years ago, is that truth has a pathetic tendency to go extinct, pretty much all the time. Truth goes extinct. The only time it has a purchase is when truth happens to align with fitness. When the fitness function is some like monotonic function of the structure of truth, then truth can survive, but only because it accidentally is tuned to fitness. Otherwise, truth goes extinct. It's all about fitness. And the interface dominates. And when we do genetic algorithms, truth doesn't even arise. It doesn't even get a chance to compete. It's just not fit enough to even to evolve. So this then leads to a view from evolution of perception, not about truth, but about creating species-specific hacks, species-specific representation systems that are tuned only to the fitness contingencies for that organism, not to the truth. Truth is irrelevant. It's only the fitness that's relevant. And fitness, mathematically, for those who are interested, is a function from the objective world into the real line. So what we're looking at is perception being tuned to a function f on the real world as opposed to the real world itself. So why truth hurts, I'll just give you the bottom line is truth. Natural selection is about fitness. It's not about truth. That's almost just normal to say that in evolutionary theory. But here's a concrete intuition why. Suppose in the real world you have some resource, for example, like water, that goes from 0 to 100, suppose, just to be concrete. And suppose that your perceptual system only can see 3 colors. You can see red, yellow, or green. And suppose that you're trying to see the truth as close as you can. So you would like, for example, there's this order relationship in the world. This much water is less than this much water is less than this much water. There's this order relationship in terms of quantity of water. For your perceptions to mirror that structure of reality, you would need to do something like this, to have, say, all of these quantities mapped to your green perception, all of these quantities of water mapped to your yellow. That way, you know that when you see green, that means it's more water than yellow, which is more water than red. So you can actually infer about the truth from your perceptions. But suppose you don't care about the truth. Suppose you're only interested in the fitness, and I've written a fitness function as this Gaussian. So the idea is that too little water, you die of thirst. Too much water, you drown. In between, just right. So there's an optimal amount for fitness. Suppose that's the fitness function in the world. The truth is this linear order. And now you want to have a perceptual strategy that's tuned to fitness, not truth, and you only get 3 colors. Then what you're going to do is do it like this. Say green is going to be the high fitness resource, yellow the intermediate, and red the low. Now, if you look at your perceptions and you say you have a perception of red, you do not know if it's a lot of water or a little water. You don't know the truth. You don't care about the truth. All you know is that that's not fit, stay away. So you don't need to know the truth, you just need to know about fitness. So how can we understand, what theory of perception can we have where we abandon truth and just stick with fitness? I call it the interface theory, and the idea is this. The desktop on your computer. Suppose you have an icon that's blue, roughly rectangular, and in the lower right-hand corner of your screen. Does that mean the file itself that you're working on is blue, rectangular, or in the lower right-hand corner of the computer? Of course not. Anybody who thought that doesn't understand what the interface is about. The interface, the colors, the shapes, and the motions are not there to tell you the truth about the structure of the computer. They're there, in fact, to hide the truth. You do not want to know about the diodes, the resistors, all the megabytes of software. You don't want to know all that. It's too complicated. So this is the goal of perception, is to hide that complexity and to give you eye candy, in this species-specific symbols, that can guide adaptive behavior. So in that sense, they're giving you a guide to the truth, but not by resembling the truth, but simply by giving you, access to fitness. So it's about fitness, not about the structure of the world. So the idea then, in the interface theory, is that when you look around the room and you see space and time, that's your desktop. Space-time is your species-specific desktop. It's just a hack. Physical objects are nothing but the icons on the desktop. To ask whether this podium, the shape and the color is the true shape and color is the same mistake as asking whether the blue icon is the right color for the file. It's the same mistake. So we like to take our physical objects quite seriously, and I'll talk about this in just a minute. So the question that obviously everybody comes up with when I bring this up, say, Hoffman, if you really think that train coming down the track is just an icon of your user interface, why don't you step in front of it? And when you're dead, and your theory with you, will know that there's far more to perception than just these icons. And you'll be happy to know I won't step in front of the train for the same reason I wouldn't grab my icon, that little blue icon, and drag it to the trash can casually. If I do that, I could lose a year of work. So I don't do it, not because I take the icon literally, the file's not blue, but I do take it seriously. And that's the key. Evolution has given us symbols that we better take seriously. If you see a snake, don't touch it. If you see a cliff, don't walk off. It's not because there are literal snakes and cliffs. Those are just a species-specific hack that's there to guide our behavior, but they're not insights. So we have this penchant to say that I have to take it seriously, therefore I must take it literally, and that's a logical error. And this means that also, the desktop gives you a fiction of causality. If I grab the icon, drag it to the trash can, it looks like the movement of the icon to the trash can caused the file to be deleted. That's a useful fiction, and it's harmless most of the time. But we know that literally the icon movement on the screen causes nothing. There's no feedback from the screen into the computer. Similarly, the appearance of causality among physical objects is just a useful fiction. And it's useful most of the time and it's harmless, except when we try to solve the mind-body problem. Then it comes back to bite us. So children, it appears, get the notion that's called object permanence when they're about 3 months of age. The idea that objects exist when they're unperceived. My teddy bear exists even when mom sticks it behind the pillow. That happens starting at 3 months and is done by the time you're about 9 to 12 months. It's an illusion that we get early on in life, and we're stuck with it all of our lives. So I feel the illusion that physical objects are real and have causal powers, and I give it no credence. But this has implications for the mind-body problem. It means that we have to rethink things from the start. So the normal way of thinking about it is, what is the biological basis of consciousness? That was how it was put in science just a couple years ago. The standard approach is to go from the physical to consciousness, and I'm going to try to go the other way. So the idea is to have a mathematically precise theory of consciousness, then the solution of the mind-body problem then has to go the other way. You have to get all of quantum theory coming out from your mathematical model of consciousness. So that's the way you'd solve it, going the other way. So, and you want to do it in a way that's mathematically rigorous, and I'd like to solve the combination problem, which I'll show you how to do in a moment, and how to tie it into physics, which I'll show you how to do in a moment. Again, I'll be precise, but maybe you'll show I'm precisely wrong. That's the whole point. But here's the idea. The plan is to take a tip from Turing. He wanted to give a theory of computation. How do you do that? Well, he got his intuitions down on a piece of paper in terms of a simple structure, a 5-tuple. A finite set of states, finite set of symbols, a start state, halt state, and a set of transition rules. Drop dead simple. And yet, it is the intellectual foundation for computer science. And it leads to, well, first he proposed, and others, the Church-Turing thesis that said that anything that's computable can be computed by this drop dead simple formalism that captured intuitions about computation. And then it led to amazing insights, like there's a universal Turing machine, which now our laptops are doing, and unsolvable problems, uncomputable problems like the halting problem. So the idea then is to come up with a theory of consciousness that's completely rigorous so that you can find out why it's wrong. So, the intuitions. I'm buying the hard problem. So there really are experiences, and our experiences are the basis on which we take actions. Those actions influence the world, and the world influences our perceptions, our experiences. I'm trying to keep it as simple as the Turing machine, but in this domain. So I'm going to just replace the world with the W, experiences with an X, and those actions with a G. And I'm going to try to make this as simple as possible mathematically. There'll be a map from the world to X that I'll call P, and it will be like a function, except that it will allow that for a given state of W, it might give you a probability on different experiences that you have, okay? So not just a single experience, it could give you probabilities. The right mathematical thing to do that's called a Markovian kernel. Similarly, given a certain experience that I'm having, there'll be a probability given by this map D on certain actions that I might take. Sometimes I might take a single action, but sometimes there might be a probability on certain actions. So again, a Markovian kernel here. And then when I take an action, there's a probability for different states in the world to occur, and I'm going to assume that this thing, I can count my experiences. That's the whole mathematical structure. So I propose that a conscious agent is a six-tuple. So it's more complicated than a Turing machine. He had a five-tuple, I got a six-tuple. And so it's this six-tuple where, for mathematical completeness, the X, G, and X are just probability spaces, which is like the weakest assumption I can make. I need to be able to talk about probability, not topology, not dimension, not anything besides probability, the weakest I could do. And the P, D, and A are Markov kernels, which means that for a given state of the world, I can talk about probabilities of various perceptions. For a given perception, probability of various actions. For an action, the probability of states of the world. And then N is an integer, counting, it's like a time, but it's just counting the experiences. That's it. That's the whole formalism. It's drop dead simple. Just like the Church-Turing thesis, I propose the conscious agent thesis. Every conscious entity and activity can be modeled by conscious agents. Again, I'm putting up precise targets so that we can precisely find out why this is wrong, if it's wrong. And then the conscious realism thesis. So this is a monism. I'm proposing a monism. The world consists of conscious agents. So let's cash that out. How do we actually cash out that in terms of the formalism? So I have two agents, agent 1 and agent 2, conscious agents, with their experience space, x1 and x2, their action space, g1 and g2, and of course the world. What I'm going to do is take this agent and plug him into the world of that agent, and take this agent and plug him into the world of that agent. That's what conscious realism says. The world consists only of conscious agents. So I'll take this agent, I'll open him up, I'll get W out of there, and I'll stick the other agent right in there. And what I get is a dynamical system now of conscious agents, a nonlinear dynamical system, and you can immediately see this can go off to infinity. So I won't go into that. I can do this, I can represent it abstractly, that this is the action of one affecting the perceptions of the other, his actions affecting the perceptions, and you get this loop. And it leads to, you can do two agents, you can do three agents. Here's the first agent, the second agent, and the third agent interacting in a loop. Here they can interact in all possible combinations. In the previous one, agent 1 only talked to agent 2, 2 to 3, and 3 to 1. But now you can have a situation where 1 talks to 2 and 3, 2 talks to 1 and 3, and so forth. So completely connected. You can have 4 completely connected, and so on. It goes off to infinity. So you can have a countable set of these, an uncountable set of these interacting in graphs. You can model introspection. So if I have the same thing I just showed you, these two agents interacting, it's a theorem, and if there's time in Q&A, I can go through it. It's a theorem that it leads to a single new agent. So this is actually a concrete solution to the combination problem. The two agents actually become a single new agent, and in terms of Giulio Tononi's integration information theory, you can show that the integrated information of the new single agent is beyond the information of the component parts. There's actually new integrated information in the combination agents. So it's not just a product of the two in the general case. And yet the two retain their identity. So you have a solution to the combination problem in which the original agents do not lose their identity, and yet you get a new agent with brand new information that's a combination. More generally, here's a non-brute. I threw this in after Dave's talk and your talk. We want a non-brute solution to the combination problem. So when you have any arbitrary graph of conscious agents, now each purple node is a conscious agent, and the arrows are which agent is affecting which other agent, and undirected arrows, they're both talking to each other. And a loop is one that has the introspection that I just talked about, where it's looking at itself as well as looking at others. So we have introspection and all sorts of interactions between them. I can pick any subset of them, and it turns out to be a theorem that that subset itself formally can be written down as a single conscious agent. Again, a solution to the combination problem. So there's nothing new, there's no new brute requirement. It's the definition of conscious agent just applied to those components, and it falls out of the definition. Nothing brute. So given any pseudograph of conscious agents, any subset, whether they're adjacent or not, connected or not, can be formed into a new single conscious agent. That's the combination. So conscious agent networks, it turns out, it's a theorem, have at least the formal power of a universal Turing machine. The reason I can prove that is that they can mimic cellular automata as a special case, and it's a theorem that cellular automata are universal. Therefore, conscious agent networks can provide a formal framework for redoing every cognitive science model that we have. In other words, it's a framework for all the easy problems in terms of, attention, perception, memory, and learning and so forth, taken just as computational problems, not as the hard problem. What's interesting is every new conscious agent model is itself, by the combination theorem, a new conscious agent. So this provides an object-oriented approach to theory building, which is an interesting new approach to cognitive science. Quickly, how this ties to physics. So this is, and what happens then. So combination is what happens next, and then physics is what happens next, and it's what I'm working on. So suppose I have two agents. This is the experiences of the first agent. He's only got one bit. He can see 0 or 1. He has only two actions, 0 or 1. This agent can experience 0, 1, act 0, 1. This is an identity map, and this is the negation map. It takes 0 to 1, 1 to 0. This is like one of the simplest conscious agent networks you could possibly have, just to make things, but they can be as complicated as you want. It turns out that when you look at the asymptotic behavior, that's when you get the integrated information being non-trivial in the Tononi sense. And you get, even in the simple case, you get two absorbing sets where the state goes from the first one is 0, the second one is 0, third one, so 0, 0, 0, 0 goes to 0, 1, 0, 0, and so forth, and it just cycles around, or you get this kind of cyclic behavior. And it turns out in general, you'll find this kind of asymptotic behavior in these. And I'm going to go through this quickly, we're out of time, but this is just from Markov chain theory. This is the equation that describes the asymptotic behavior of these Markov dynamics of conscious agents. It's called eigenfunctions, where S are the states, like 0, 0, so forth. D is the cycle period, like 8 in the example I just gave you. K is an integer between 1 and D, and N is the time step. Now, the kinds of tie-ins with physics that this is where, I'm trying to make the tie-in with physics, and this is work to be done. Here's the wave function of the quantum-free particle. Here's the conscious agent asymptotics. The equations are formally identical. And this allows us to make first the assumption, or the claim, to be falsified, that quantum mechanics represents the asymptotic behavior of conscious agents. But I have the whole behavior, not just the asymptotic, which means I should be able to make new predictions. So this means that I can actually go through and make clean tie-in between, for example, the states of my agents and space, wavelength in physics and properties of my agents, the speed of light is 1 in my units, momentum, and energy. They all have, so this is, on the left side is on one side is physics, the other side is consciousness in each one of these equations. In each one of these equations, there's a mapping between physics and consciousness. Where am I going with this? That was non-relativistic. The relativistic, I want to, and this is again work to be done. I'd love to get a physicist working with me on this. But this is again what's more, what's next. Get two conscious agents working together like this. You can get what's called a geometric algebra of signature 2, 4. And it turns out that this is the geometry of the space-time conformal representation of quantum mechanics. So it gives you massless, supersymmetric representations in quantum mechanics. So I'm going to try to make the tie-in between pairs of conscious agents and supersymmetric models of quantum physics, and try to get Dirac spinors and eventually even Penrose twistors coming out of it. So for future work, trying to get a map from these conscious agent networks to quantum field theory, everybody wants quantum gravity, and then a generalized evolutionary theory, because I've got to rework evolutionary theory. Most evolutionary accounts are physicalist, but there is a notion of universal Darwinism where we can pull it out of the physicalist framework and put it in the framework of these conscious agent networks. So I'd like to get an evolutionary theory on conscious agent networks in which information is the limited resource and the source of competition. And then the constraint on that theory of evolution is that when you project it back to the space-time interface of Homo sapiens, you get back Darwin. So the current evolutionary theory would be the boundary condition on that more general. And then continue to work on the combination problem. And with that, I think I should stop.
Let's have Dave and Dan come up, and we'll have a little panel and a few questions from the audience. And we're going to run late, but we'll push the concurrence back. Let me ask Don, are you agreeing with Dave that consciousness causes collapse, that your interface or icons are acted upon by consciousness coming from the outside, causing reduction to particular perceptions?
Yes, by claiming that consciousness is fundamental and the claim of conscious realism is that it's a monism. So all that exists is consciousness. So the only thing that could ever collapse anything would be consciousness itself, and the only thing that could be collapsed would be a representation from consciousness. It's a monism.
You want to reply to that, Dave?
Well, actually, one question I have about your view is sort of fitting it into the framework I was discussing, was whether it's roughly a form of idealism with the whole mind inside, the whole world inside the conscious mind of some conscious observers. We're a limited class of conscious observers, maybe humans, maybe dogs, but not all the way down to particles. Or rather, whether it's a form of panpsychism, with conscious agents all the way down. So I'm a conscious agent, you're a conscious agent, and there turns out to be a separate conscious agent for every photon and every quark and every fundamental particle, because these look like quite different views in the end.
Yes, I think it's neither, but it's closer to the panpsychism. It's consciousness all the way down. The reason I don't want to say it's actually panpsychism is that I don't say that there are photons or quarks or anything like that that exists apart from consciousness. So space-time itself is nothing but a species-specific hack. And anything that's in space-time, including particles, is nothing but a representation of consciousness. So it's not that the individual physical entities exist apart from consciousness and also have consciousness.
Every now and then we discover something new in the physical world, right? Maybe we make observations of the Big Bang, or we discover a new fundamental particle, or we go to a new part of the universe. And the question is, what's going on then? On one view, that was already part of our conscious minds. Somehow the Higgs boson or those gravitational waves at the Big Bang were represented in the back of the unconscious depths of my conscious mind, and it's just coming to the surface. On another view, that's independent of my mind. It's out there in reality. then the question is, whose mind is it in? Not in any of our minds. It looks like this way of thinking naturally leads one to a kind of a broadly panpsychist view where there has to be conscious agents for every level of reality.
Yeah, I agree that there are conscious agents for every level of reality, and that there is an objective reality beyond my perceptions. So there is an objective reality independent of me that exists whether or not I perceive it. But conscious realism proposes that that reality is other conscious agents. So in that sense, it's panpsychism, as long as I don't have it that photons also have consciousness. I'm not saying that, because photons don't exist in this theory except as symbols.
Once we have consciousness at every level, does it then turn out that we are constituted, we are complicated conscious agents made up from all the little conscious agents in our brain?
Yeah, we are ourselves the result of this combination theorem. So you are a single conscious agent, but also the result of, who knows, an infinite hierarchy of combinations of conscious agents that goes all the way down, and we may be part of other combinations that we're not even aware of because we don't lose our identity. The theorem says you do not lose your identity when you participate in a higher combination.
Sounds like a time for the cop at Woodstock. Dan, would you like to?
Yeah. Yeah, just so. That was fascinating talk, but I'll tell you why I'm not persuaded by your models, especially the evolutionary models. Having spent, a fascinating day once with John Maynard Smith and David Ackley trying to come up with interesting computer models of the evolution of, in our case, we were working on the Baldwin effect. We're getting nowhere. We kept trying to make it happen, and what we finally realized was if we succeeded, we'd have a big problem because the agents in our model were simpler than bacteria. And if it worked, then why aren't bacteria speaking natural language, for instance? The problem that I see with your models is your nodes, which you're calling agents, that are these epistemological, the question is, are they trying to get at the truth? They are simpler than bacteria. Well, it doesn't surprise me that, as far as evolution is concerned, bacteria aren't going for the truth. They're not complicated enough to go for the truth. Once you've got a multicellular animal like a fox that has to look out for other predators and find his food and take care and find a mate and all the rest, once you add all that complexity, I don't think your model will have the same result. I don't think you're going to show that truth goes extinct under those circumstances. I think you'll find out just what all the textbooks say, that by and large, our senses are extremely reliable at getting at what? Reality as seen through the lens of what Sellers calls the manifest image. Indeed, we see the world that matters, the Gibsonian world of affordances. And evolution figures out which affordances matter to which species and arranges for evolution. Evolution then arranges for the perceptual capacities to be really good at detecting the affordances that are going to keep it alive. Now that's truth plus fitness. So it's not fitness as opposed to truth. It's truth as it's specialized truth, species specific to be sure, in order to make more fit. So we're right back to the textbooks, to Steve Palmer and the rest of them.
Well, a couple things. First, the nice thing about using evolutionary games is that they are mathematically precise. So you've made a precise claim. As we create more and more complicated organisms in our models, we can test it. So we won't have to hand wave. But second, in many cases, it's not the complexity of the organism that's critical, it's the strategies that they have. And so when we do the prisoner's dilemma, we look at evolutionary games based on that and so forth, we don't really worry about how complicated those organisms were. It's just, do they implement that strategy? And so truth and fitness are strategies that could be implemented by bacteria, or they could be implemented by you and me. And so when we have in our evolutionary games looked at the role of complexity from very, very simple worlds and simple perceptual maps to as complicated as we could make them, we were expecting to maybe find that truth would get a purchase as things got more complicated. And in fact, it went the other way because there's so much stuff to keep track of that it was starting to die under the weight of all the information and the costs of that. So what we found was that as the world got more complicated, fitness actually wins over truth, and truth went extinct.
Well, just one. I'm going to have to look at the models carefully. My hunch is that, like most of those models, they're helping themselves to epistemological language when there's no clear justification for it.
Deepak.
John, would it be fair to summarize?
Louder. I don't think it's on.
Would it be? Can you hear me?
No.
John, can you hear me?
Not very well.
Can you hear me? Would it be fair to summarize your model of conscious realism by just the following statement? Consciousness creates the activities of the brain and the objects of the world.
It certainly is the case that instead of saying that brain activity causes consciousness, I'm forced to say that consciousness comes first and that neurons are symbols that's created by consciousness. So in supervenience terms, the typical supervenience relationship is that consciousness supervenes on brain activity. I'm reversing that. I'm saying that brain activity supervenes on consciousness.
Are conscious agents qualia gestalts species? Are conscious agents qualia gestalts species specific
Yeah, the
with
idea...
their own qualia vocabulary?
Right, so the idea would be that evolution shapes different organisms according to their niche with perceptual systems that deal with the fitness issues that they need to deal with in their niche. So they are species specific in that sense, absolutely.
Sue. Stand up.
It's unfair that Don gets all the questions because he was last, but I'm afraid that's in my mind too. You seem to be saying that Higgs bosons and the Big Bang and so on come out of consciousness, but you've also said that there is a physical world. Can you say anything about what that is?
So the idea, what we call the physical world, is a species-specific projection of this vast range of conscious agents that are interacting into the space-time framework of Homo sapiens. So that's what we call physics, is that projection into our space-time framework.
Projection of what? You also
Of conscious agents. So the idea is, as a conscious agent, I have finite representational capacities, whereas I'm proposing that the set of conscious agents is infinite. So that means there's an infinite objective reality out there. I have finite resources, so most of it I don't represent. And that's why we talk about unconscious processing, right? So we say that much of brain processing is unconscious. What we're doing is we're mistaking a limit of our perceptions for an insight into reality. It's just a limit of our perceptions. Of course, we can't see everything, but as a species, we have the penchant of saying that the way I perceive it must be the way it is. So the idea then is that it's all species specific, and I'll just leave it at that. Yeah.
I want to specifically address species specific. I was with you when you first started going down that path until you failed to take what I think was a rather well-known detour. And that is, yes, for every species, for the myopic anteater for whom ant is a mass term, just more ant, to the insectivorous bird for whom insects are individuals, evolution sculpts the affordances that matter given that organism's equipment and needs. That's so far, we're all species specific. In the case of one species, and one species only, Homo sapiens, we have, because we have language, have learned to compare notes, have got the concept of truth, which probably no other species has anything like it, and we've begun to appreciate the very fact that I just articulated, that you've said, and realize that there is a way to leverage ourselves, bootstrap ourselves out of our species-specific predicament. And this has had wonderful results. We've invented microscopes and telescopes and infrared, and the whole of the scientific image, what Sellers calls the scientific image, is the product of that wonderful effort by one species to overcome the species-specific limitations that evolution has granted it. We can measure to n decimal places how far off accurate somebody's vision is, how somebody's hearing. We can measure which part of the spectrum their vision is sensitive to and which it isn't. This creates our belief in the objective reality of the world as described in the scientific image. But you don't take that path, and I don't know why not.
Right. I don't take that path because I take space and time to be, and the predicates of space and time, to be a species-specific adaptation and not an insight. So in physics, of course, we will then take it to the next step. We'll use group theory, Euclidean group, Poincaré group, and other groups to extend the predicates of perception to the more general case, but there's still the predicates that we inherited. So I think the intellectual history of our species is slowly giving up the idea that the way we perceive the world is the way it is. So we thought about flat Earth. Why? Because that's the way it looks. We gave that up. It was hard, but we gave it up. Then we had to give up geocentric universe, and people died over that one. And again, why was it so hard to give up? It sure looked like the sun and the moon and the stars went around the Earth. It was hard for us to give that up. I'm saying the next step is space and time themselves. Flat Earth and geocentric universe were just warm-ups. Now as a species, we have to give up space and time and physical objects themselves because, okay. But I hasten to say, in a mathematically rigorous way, right? So what I want to do is to take my theory of conscious agents and get back, not less, but more than quantum field theory and eventually quantum gravity. So the burden on me is to get everything that current physics has gotten, but to understand that all the precision you talked about is just the precision of a interface adapted for fitness, not truth.
Okay.
So that's the people in from the audience, I think.
This is a question for Dan Dennett. Can you venture a guess as to when you think people got that cognitive illusion, as you said, and who else may be prone to the same illusion?
Well, if you look at the history of thought and go back and look at the ancients, which is where David started, you see that they had some very naive views about how perception worked. They had a sort of projection theory. Of course, Hume famously said the mind spreads itself upon the world, but he meant that metaphorically. I do hope and I do believe. But earlier people had seen it the other way around, as something going out from the eyes rather than photons going in and being processed. They saw something marvelous and magical going out. So I think that there have been deep-seated illusions, cognitive illusions about the nature of experience for as long as we can recover in recorded history. I think that the more recent manifestations of this have been heightened and sort of crystallized by ideological warfare of a sort of propaganda campaigns, which have driven home to people these images of, for instance, the hard problem. It's very catchy, but I think that's all it is. It's like a jingle that you can't get out of your head. It's advertising toothpaste.
Over here.
Hi, my name is Kartik Subbarao. My question is for both Dave and for Dan. To the extent that you're self-aware, why do you study consciousness? Why is it personally important to you? Thank you.
Number one, I think it's the single most interesting problem in the universe. But number two, I think, okay, it's the central datum of our existence. And maybe this is the biggest difference between me and Dan, is that I take consciousness basically to be a datum, which is by its nature to be explained and not to be explained away. You know, there are all these facts about behavior and functioning, to be sure, which is great to have a theory of, but then there is subjective experience, datum, to be explained. So one, it's at the very center of our universe, and two, it is the single thing we do not understand. I actually started out in physics and mathematics and used to think, Wouldn't it be great to be studying this stuff 300 or 400 years ago, when we were just beginning to understand it? And there's a lot we don't understand now about in physics and mathematics, but it feels like in some sense, we're filling in the picture. Consciousness is the phenomenon in the universe that we do not understand. Maybe in 200 years' time, we'll get lucky and say, yes, it was at that Tucson conference in 2014 when Don Hoffman finally solved it, or when Dan Dennett cleaned it up for once and for all. Anyway, it seems to me that this is the subject right now for someone who's especially intellectually curious.
Well, I agree with David. It's the most interesting problem I know, and the most interesting unsolved set of problems that I know. And I think we now have the tools. And when I say now, I mean we have them today, and we didn't have them when I started 50 years ago on this. We're getting new tools for making progress on this every year, both mountains of data and new conceptual schemes, new ways of thinking about computation. We're getting away from simple-minded theories of computation and all the rest. So I think it's a golden age for solving the easy problems, which are the only problems that really exist. And they're none too easy. They're none too easy. Answering one example, if you read David Huron's book, Sweet Anticipation, it's about music in the brain, and there he will explain to you why do, re, mi, fa, sol, la, and ti, and do have the qualia that they have. He deconstructs the qualia of the scale tones. Now, a lot of philosophers say, that's impossible, it's inconceivable. No, that's a failure of imagination on their part to think so. But the other reason I think the problem of consciousness is so hard, I didn't get to this, it was one of my last slides, is that for many people, it's not a scientific issue. It's a sort of an aesthetic issue, or more particularly, it's a moral issue. A lot of people, and be honest with yourselves, they really don't want type A materialism to be true because they think the vision of us as, meat machines is demeaning and leads to nihilism, and that you can't have free will and love and meaning in that world. That, I think, is a big mistake. And of course, anybody who knows my work knows that I've tried all along to show, yes, this view is friendly to meaning, to free will, to morality, all of these good things. You don't have to have a mysterious mind pearl to make sense of those things. So I continue in my deliberately conservative way to try to be a type A materialist. I don't see any insuperable obstacles standing in the way, and I see a lot of progress. And I'm sure the rest of you are having fun with your theories, but I don't see that they're needed, and so that's good too, because I got to admit, it would be an awful lot of work for me to understand Donald's theory.
Burton Voorhees.
I guess I do agree that we're making more progress on the easy problems than on the hard problem. That's because they're easier. I mean, what do you expect? But I do want to disagree on this one last point, the thought that it's somehow a moral or quasi-religious need for reductionism to be false. I think this is just brought out to be wrong sociologically. Look at all the people I mentioned, the Pinkers, the Kurzweils, the Cricks, the Kochs. These are people who really want some form of reductionism or materialism to be true. There's a deep-seated aching for all this stuff to be explained in terms of the brain or computation and so on. But even these people, at the end of the day, say, well, there is just scientifically, intellectually, philosophically, a residual issue here. And I don't think it's particularly plausible this is a little vestige of religion or moral fear in them. It's just paying attention to the data and saying we've got to explain the data to be explained.
Well, no, I think in the case of your foursome there, nobody's perfect. They've all been taken in by you.
This even includes your fellow new atheists, right? Sam Harris, even Richard Dawkins. I've seen him softening up a bit in the hard problem. Anyway.
Okay, Burton.
Okay, this question is for Don, and I'd like to get a little bit more clarity on you did mention that you believe there is a world out there, that it's not just the interface. And when you constructed your conscious agent, one aspect of that was the letter W for the world. And then you put another conscious agent in there and took off. But I'm wondering if that world also includes things that are not conscious agents, or if everything's a conscious agent.
Well, right now, I'm trying to see how far I can go, where I make the assumption that the world consists only of conscious agents. Now, maybe it's a precise claim, so we can now try to test that precise claim and see if it's precisely wrong. But so the idea is a monism, and to then test whether we can get all of current science from that. So that is the objective world. It's not a physical world, it's not space and time. It's a world of conscious agents that's not in space and time, and it's not physical.
We're going to have one more from the audience, but I want to ask Dan a question. In your image of mental time looping backwards, as I recall, was an effort to negate Libet's backward time referral. Wasn't
No,
that?
it wasn't. It was my explanation of the color 5 phenomenon. But what do you want to ask me about Libet? Because I've got strong views on that too.
Because I think the backward time referral was real. We now have evidence in quantum physics of backward time referral. We had Daryl Bem speaking last time about things from the future, and we have a talk. So you're ignoring facts. Those are facts. Those are evidence.
It's a fact, I gather, from what you say, that Daryl Bem gave a talk. I accept that.
You won't be here, but there's a talk Thursday morning about backward time effects. You should stay.
So my question is actually about the very interesting coleopterans from the outback who are making a very conscious decision to mate with the beer bottles rather than with the females. Still, we made a very conscious decision of interfering to save the species. So where is the evolutionary gain or loss from having consciousness?
Oh, where is the evolutionary gain or loss from having consciousness? Okay, so
if I may restate, if you can hear me, I was wondering about the conscious decision that the beetles made to mate with the bottles rather than with the females. I mean, they may be trying to save the world by not procreating, till we interfered with our consciousness. So where is sort of the evolutionary benefit of that? Is it more of a cost? Is it a benefit? This concept of consciousness.
I'm not sure how to answer that question. I can say that if conscious realism is correct, then the only thing that has evolved is consciousness. And the standard evolutionary theory will have to come out as a special case when we project an evolutionary of consciousness theory onto space and time. In terms of the beetle, I don't know about the moral aspects of our consciousness and what it did for the beetle. My only point there was simply to use the beetle as an example of the fact that our perceptions may sometimes appear to be clever and insightful when in fact they're just hacks. That was my only point with the beetle.
All right, I think before we thank our speakers, let me just say that we will postpone the beginning of the concurrence till 5:15. And as soon as we thank our speakers, we'll ask you to exit this room so the team can break it down into concurrent rooms. And with that, let's thank our all-star panel here for a great session.